Tina, so can I say hello? Pradipto, am I audible?
Yes, sir.
Okay,
Yes,
can
sir.
I?
Yes, sir. You are
Okay,
audible.
so please note it down. So first, okay, what you need to write in the first you have to prepare in soft copy in MS Word. Okay, then you prepare that Word document. After that, you have to convert in the PDF. And your seer Rahul Shamul, okay, Rahul will share you one link, Google Form link, where you need to write your name, roll number, mail ID, and you have to upload the PDF form of your write up. Okay, so for individual classes, individual write up will be there, like your individual means today we will discuss about simulation, first simulations. So when you will attend my next class, means next Friday class, you have to submit that submit that write up before starting the class. Okay, so that link will be enabled by today, and it will be disable. The timer will be there, it will be disabled before starting of my class. Maybe next Friday the class will be 1:15, it will be disabled maybe 12. Okay, or before 1:15. Okay, so it will be set, I will discuss with Rahul and the timer will be given, but it will be enabled by today night. Okay, so what you need to write to your write up. Okay, so first point you have to write, it is actually computation and analysis, means simulation lab. So first you need to write down the simulation lab 1. Okay, so first item means experiment number 1. So first is your experiment number 1. Okay, then you have to write the title of the experiment. Okay, so title of the experiment that already been discussed in the first class. Okay, if you have forgot the name of the experiments, you can I have also shared that video link. Okay, I have already shared. You can listen the video, means audio link. You can listen the name of the experiment and give the name. Okay, then second point, first point is the title of the experiment. Second point, first just above of your experiment, so you should write the experiment number. Okay, then title of the experiment. Okay, third point, aim or objective of the experiment. So what is your objective of the experiment? I am taking one example, just like you can say like that. So title of the experiment is given, the analysis of voltage and current analysis, maybe like that I am taking one arbitrary title. Okay, so voltage and current analysis of uncontrolled rectifier, full bridge uncontrolled rectifier with R load, RL load and RLE load. So what is your objective? Your objective will be number 1, to study the to study the voltage and output voltage and current, output voltage and current characteristics. Okay, current characteristics of uncontrolled full bridge uncontrolled rectifier with R load. Okay, to study or to first point. Second point is second objective, to study the voltage and current waveform of your full bridge uncontrolled bridge rectifier having RL load. Okay, third objective is same thing with RLE load. Okay, like that. So first you have to write the experiment number, then name of the experiment, then objective of the experiment. Then fourth point is the theory. Theory means what you need to write. Okay, first in theory, first it will come the circuit diagram. Okay, so you have to you have to use for circuit diagram. Okay, first you have to write the circuit diagram. Okay, then draw the circuit diagram, then you have to discuss about your circuit. So from where you will get the discussions, everything, it will be available any of the standard power electronics book. Like in your when Professor A.K. Panda was taking your class, actually sir suggested some books. Okay, you can know that Rashid books is very renowned one, then Nedmohan book. Okay, Rashid, Nedmohan, Erickson, Philip T. Crane. Okay, so these 4 books are very renowned books. Okay, that also the soft copy also be available in internet. Okay, so you can download it. Okay, I think some of you have, some of you already have this the soft copy of the book. Okay, so some of you, if you don't have it, so some of your friend have it. Okay, so you can collect it. Okay, so you can follow the standard books and write your theory, but do not follow the Bhimra book. Okay, power electronics book written by Bhimra, a lot of mistakes are there. Okay, that's why I am not suggesting the book of Bhimra, but machine book written by Bhimra is very good. Okay, so but the book for the power electronics written by Bhimra, you should not suggest it. Basically, some of the lot of mistakes are there. Okay, so it is, as a teacher I cannot recommend you to follow that book which having lot of mistakes. Okay, it should not be. So you can follow any of the world famous author, means power electronics person. Okay, that I have told you that 4 names of the power electronics book author. This is renowned books throughout the world. Okay, so you can follow them. So theory part is there. So theory, basically you discussed about the circuit diagram and the waveform characteristics. Okay, from the theoretical books. Okay, what are the important discussions was there about the circuit, that is covered by the theory. The next point is your procedure. Okay, so procedure means how do you simulate it in the multisim, the procedure to simulate it in the multisim. Okay, so first you can write down, we can open the multisim. The procedure is almost common for the all the experiments. Okay, then first open the multisim. How do you open it? Means select that select button, then Windows button, then select the multisim, then which portions open the file. Okay, so what is the name of the extension? Okay, file extension name also very important, na? So when we are designing the GUI, means graphical user interface, I think so. Okay, GUI design means we should know about the extension of the file. Like MATLAB, normally where we have written the code, okay, means script, that is M file. The extension is .m. Where we have simulated, initially it was .mdl file. Another file is also be there, .slx file. Okay, MDL file size is quite big compared to the SLX file. Okay, so also in .dat file means .dat, dat file means data file. In MATLAB we are not using DAT file, .mat file, mat file. In MATLAB data stored in the mat file. Okay, so that extension also important, the which type of extension you have observed here. Okay, then procedures you need to write. Okay, then drag which components, then series name, the component name, which part number you are using. So when you are dragging the component, you should aware about it. Is it power diode or is it signal diode? If you are dragging the power diode, dragging the signal diode instead of power diode, in simulation it may be work, but practical cases means when you are really working with the power electronics converter, so it will not work and it will be immediately it will burn out. Okay, so when you are selecting one component by drag and drop from your from the list given by the multisim, so you should concern about the part number of that instrument. Okay, part number of the devices. So what devices you are using, so you have to write the device, you have to check the device. Okay, so in Google, is it power one or is it analog one? So after getting some of the experiments, no need to check it in Google. So we are normally using power MOSFET like IRF MOSFET we are using, IRF P450. Okay, so then another I am telling about the power diode. Okay, mood diodes are that. Okay, so STB55AN, these are the examples of the power MOSFETs. Okay, the same analog MOSFETs also been available, but we are not interested on the analog devices. Okay, we should give the main thrust on the power devices. Okay, but when you are designing the control circuit, in control circuit, that for the generating the gate pulse, everything. Okay, so that also depends upon your analog device. Basically, the power level of the control circuit is maximum 15 volts. Okay, so 15 volts means analog devices are sufficient to working with the 15 volts. Okay, and you can generate the gate pulses from there, and that gate pulse will be fed to the switch of the power converter. Okay, through the driver circuit. Okay, that's a basic concept. Okay. So you should think about it at the time of procedure. So how to design it. Okay, then after procedure, what you need to write, then it is coming the simulation results and discussion. Simulation results means specification. So now you have to draw the circuit in the multisim, or if you are using MATLAB, so everything is there. So you have to drag that you have to copy the circuit from multisim platform or MATLAB platform to paste your Word file. Okay, so what are the specifications, what are the parameters you are using? If you have that MOSFET, so what is the specifications of the MOSFET? Okay, sorry, if you are using the full bridge converter, if you using the full bridge power converter circuit, okay, what is the specifications of this circuit? Means what is input voltage, what is your output voltage, okay, what is the voltage level of the devices, okay, solid state devices. Okay, if you are using the MOSFET, the switch, actually which switch you are using, what is the voltage level. Okay, so if your voltage level is 50 volt and if you are using IRF P450, so what is the voltage range of IRF P450? 450 means it is 400 volt MOSFET. Okay, but you are giving the 50 volt as an input of the full bridge converter. Okay, so unnecessary you are giving 400 volt MOSFET. It is not required. So you can use STB 555N. Okay, STB 555M, how much voltage is it? It is 55 volt. Okay, so that is sufficient, okay, to drive 50 volt as an input, but sometimes spike will be there. So that's why normally if twice of your input voltage, normally the convention is that twice of your input voltage, the selection of the switching devices. Okay, so if your input voltage is 50 volt, so you have to select the switch twice of your input voltage, means 100 volt MOSFET, power MOSFET you have to select. But I am not telling you to go very in-depth study, but those students are interested, okay, they can prepare their material such a manner. Actually, you are almost just a few months in your hand. After that, you will be a graduate trainee. Okay, you will be an assistant manager. You will be an assistant manager in any of the esteemed or any of the renowned industry, any renowned organizations. Okay, so you have to think your work in such a manner that when you will join there, so you can see two type of people. Okay, some of the person having lot of knowledge, experimental knowledge, means practical knowledge, lots of practical knowledge, but they don't have lot of theoretical knowledge. But you should have the combinations of the basic theory as well as the practical knowledge. So you have to grab the practical idea from their side. Okay, and definitely you did the BTech, means definitely you have the good technical knowledge, na? So, and some of the person having good technical knowledge but don't practical knowledge, but you have to grab the technical knowledge. Okay, practical means real time technical knowledge you have to require, okay, to compete with the other person, or otherwise your subordinate will not give you proper respect. So you have to select, you have to go such a manner, you have to train yourself such a manner, so there should not be any chances, you should not give any chances to the other person to dishonor you. Okay, basically you will be the superior, na? When you will join there, so you will be in the assistant manager rank. Okay, if your superior means your junior or your subordinate will not give you the proper respect, so that dishonor is not been acceptable. At least from my side, it is not acceptable. Okay, so I think you are all are my students. So definitely you have the same kinds of mentality. So you have to think very smart way. Okay, that I am telling you. So selection of the parameter. Okay, so switching devices, selection of the switching devices. So that important issue. Unnecessary, why you are giving the more cost on it. So if you have 20 volt MOSFET, 20 volt as input, so that STB55 is sufficient. That voltage level is 55 voltage, and twice of your 20 volt is 40 voltage. Okay, that is sufficient enough. That MOSFET cost only 15 rupees. But if you go for that IRF MOSFET, that MOSFET cost for 75 rupees. So cost savings of the means cost savings is mandatory. Okay, so in industry, that one device, selection of the device of any of the thing, so it is important. Otherwise unnecessarily the customer should give their more penny to provide the more penny for purchasing the devices, no? Purchasing the product. So we have to think such a manner, smart manner. Then result section, the waveform will be there, and discussions is mandatory or necessary. After the result section means simulation results and discussions. Okay, total thorough discussions and thorough simulations, how much you can get the waveform from your standard simulation, voltage waveform, current waveform, if voltage and current are in same phase, okay, why it is coming. Basically if it is R load, so they will be the same phase, but in case of RL load, the definitely waveform will be different. Okay, input current waveform. Okay, so different waveform as well as their discussions. And finally you have to write down the conclusion. So conclusion section means, in conclusion section you have to discuss about the discuss about the observations. Okay, that what you have observed from the results. Okay, from the results section. So you are comparing the R load, RL load and RLE load. So in R load what you have observed, and RL load what you have observed and conclude from that study. In conclusion section is most important. So you have to discuss about the studies, means what kinds of observation you have noticed from the entire simulation and what you can conclude from the studies. So that will be written in the conclusion section. Okay, after the conclusion section another portion is there, that is called bibliography or the reference. So you put the name of the resources, like you are following Rashid book, so you can put the name of Rashid book. So the citation, that is called the reference. So how to get the citation from the Google Scholar, you have to see how they are providing the citation. So you can follow IEEE format, no problem. Okay, and another reference is there, NI Multisim software manual. If you are using MATLAB, so in that case you have to mention the MATLAB, that means handbook of the MATLAB. Okay, so that's the way. So you have to prepare the write-up. Okay, I think all of you able to understand. All of you able to understand what I have discussed with you, what I have suggested with you. If you have any kinds of query, you can ask me. Okay, anytime, any time you can ask me. Okay, so I think all of you able to understand what is my means, what is the objective of my discussion. I think, is there any doubt from Pradipto? Is there any doubt from your side?
No, sir.
Vikas? Hey, Vikas from the Patro.
Sir, present, sir.
I am not asking for your attendance. I am asking you that do you understand what I have discussed here right now?
Yes, sir.
Yes, sir. Okay. Do you have any doubt?
Please help me.
Do you have any doubt?
Yes, sir. Sir, simulation is stopping unexpectedly.
Simulation is?
I mean, during simulation, it is stopped unexpectedly. I mean, there is some kind of error.
Okay. Today you just attend the session. Ramaprasad sir is with us. Okay. He will show you the basic simulation of the experiment number 1. You just follow that path. If you faced any kind of problem, sometimes what happen, the parameter selection. Okay, so sometimes what happen, the selection of the parameter. Okay, so selection of the parameter, maybe by mistakenly you have chosen wrong thing, maybe the simulation time. Okay, that's why it has stopped. Okay, basically the problem is that kinds of problem has occurred. Okay, so you just wait for another few minutes. So Ramaprasad sir is here with us, so he will discuss some of the experiment number 1. So you just see. Okay, after that, if you faced any kinds of problem, we are ready to give you all the answer. Okay. Okay, then is there anybody? Amartya? Amartya?
Yes, sir.
Are you able to are you understand? Sorry, do you understand what I have discussed here?
Yes, sir.
Okay, so next Friday, okay, all of you need to submit the report. Okay, so today is the only second class. So today we will discuss about the first simulation. So next class you have to submit the write up of the simulation 1. Okay, so Vaibhav.
Yes, sir.
Okay, so do you have any kind of doubt about the write up about the preparation of your write up? Do you have any kinds of doubt?
Excuse me, sir.
No, sir.
No. Okay. Surdul, tell me.
Sir, MATLAB use करना है या multisim?
Some few of the experiment we will discuss. Means we will follow the multisim. After that, we will use the MATLAB. Both of the software will be used here in this class. Okay. Okay. Thank you. So I just request Ramaprasad sir to.
Sir. Good afternoon. Good afternoon.
Good
and
afternoon.
Happy New Year to sir. And happy New Year to all students. Okay.
Happy New Year, sir.
Happy New Year, sir. Happy New Year.
Happy New Year, sir.
Yes. Happy New Year. Happy New Year.
sir.
Happy New Year. Happy New Year. So sir already told everything for you. So you have to follow that procedures as sir has told. So as somebody was telling that during simulation unexpectedly it is just stopping, means that simulation run being stopping. So you just uninstall the software again you reinstall it. I think during installation some file has been corrupted, that's why that kind of problem arise. So you uninstall it again, you reinstall. Okay. And another thing regarding your parameter editing and your
Sir, I think, sir, that parameter issue, sir, because all other different.
Okay. No issue. You have to change the parameter. Then that kind of maybe means you have not put ground in that circuit. If you not put ground, that kind of simulation error will come. Or parameter setting, if you have done some edit some wrong parameter, then that kind of error will come. So many issues are there, but you have to means analyze which kind of, or you have to find out which kind of fault you have done, means during simulation is being occurring. So today is the fast, means I am going to explain today the fast experiment, that is analysis of single phase half wave diode rectifier or uncontrolled rectifier using various loads, that is R load, RL load and RLE load. So I will show you one simulation and accordingly you have to do all simulations. So using one load I will show you and I will tell you what are the various ways and various tricks to get same waveform of a circuit. So there are so many ways or so many tricks you can follow any kind of means any process to get output result. Okay. So manually, as you are doing hardware simulation, you can do same kind of simulation in multisim, or in case of MATLAB, as you have already done some a lot of experiment in MATLAB or Simulink. So in that in case of MATLAB, we are editing the data and going through simulation directly. You are getting waveform. So in multisim, both options are available. Manually, how you can do that thing you can also see, or you can also simulate. And using simulation means analysis method, simulation analysis, you can directly get the waveform. So I will show you different tricks to simulate the circuit. So circuit parameter should not be same for all students. It should be vary from student to student. Explanation should be differ from student to student. Output result waveform should be same, but value should not be same. Value is depending on your circuit. So whatever the components or whatever means what are the process or analysis you have used, you have to put the screenshot of each and every steps or each and every parameter setting or source setting or simulation procedure. So that screenshot you have to put in proper place. Okay, so as I has told everything, so just you remember your record should contain first title of the experiment, then software, which kind of software you have used with version, then then your circuit diagram, then circuit diagram, then theory should be, means you have to explain the theory, not means important theory, the required part. Okay, only the keywords or key theory you have to write, not all the things. Okay, so then procedure, what procedure you have done to simulate the circuit, then step by step you have to write the procedure. Then you have to in circuit diagram you have to put the screenshots of the parameter setting, means which kind, means how much value of inductor or resistor or capacitor you have used, that values. If the value is directly showing, then no need to put the screenshot. If it's not showing, you have to put the screenshot. Then source setting, what means source setting, what are the value you have given in source, that may be AC source or DC source. So source setting screenshot should be they means should be in your record. Then after analysis, which analysis you have done, you have to put the screenshot of the analysis block or analysis table. Then that analysis, then after getting the screenshot, then you have to paste the waveforms, what waveforms you got, like input voltage, output current, or diode current, whatever the means output you need, you have to trace the signal, as well as you have to measure the value of voltage or current or any parameter using measuring instrument like voltmeter, ammeter, wattmeter. Everything is available in Multisim. So that measured value, that may be numerical value, that is magnitude or waveforms, that should be, you have to put in result or waveforms. Then after if calculation is required, it is not required in all experiments, but some experiment if calculation is required, then you have to put the calculation. Then you can directly means you can do the calculation in Word file, otherwise by writing in hand you can copy and paste the, take a photocopy, paste it in your record. So calculation part you can do like that. So then calculation, then comparison, that is the calculated value and observed value. Then find the percentage of error. If error is there, means if you are getting some difference in calculated value or measured value, then how much the difference is coming, then find out the error. Then then after you have to put your conclusion part, what conclusion you got. So in this way you have to prepare the record. A record should be vary from student to student. Everything should not be same. We'll check the records. If you'll find any common thing, means we are getting any common things, common written, common circuit diagram, words, everything if common, then those students will be evaluated. That means you will find out those students and your evaluation will be decreased, means you will reduce your marks. So please, my request, in a new year I suggest you just create a dream and you encourage yourself and put your effort 100% and continue the lab with a successful manner. Okay, so I hope all can receive my suggestion. Okay, so let us start today experiment, that is I am showing the simulation, that is single phase half wave uncontrolled rectifier. It is a simple diode rectifier. So sir, screen sharing is disabled now. Hello Arnab sir, hello.
hello रामाप्रसाद दा
सर स्क्रीन शेयर अभी डिजेबल है. मैं एक काम करता हूँ, मैं जैसे लास्ट टाइम किया था ऐसे लीव होके और एक बार ज्वाइन करता हूँ. ठीक है,
आपका डिजेबल है, जस्ट वेट कीजिए 1 मिनट, जस्ट वेट फॉर अ मोमेंट. आपका डिसेबल तो नहीं होना चाहिए। ओके ओके, हाँ हाँ हाँ, जस्ट आपको लीव होने का जरूरत नहीं, जस्ट वेट, वेस्ट फॉर मोमेंट।
अच्छा
आप लीव मत होइए, आप देखिए स्क्रीन शेयर हो रहा है
हाँ
आपका?
सर, हो गया अभी
Okay.
आ गया सर। जो डायोड लास्ट टाइम लिए थे सेम
हाँ
डायोड लेंगे ना?
हाँ, मूड डाइट एमयूआर। ओके
एमयूआर कुछ भी सीरीज का ले सकते हैं ना, ठीक है। ओके, student, the screen is visible to all, is it visible?
yes yes, it is
So now okay. So if you face any kind of doubt, you can ask me. So now I'm going to start. So from the experiment, it is written single phase half wave rectifier. So input should be AC. So from the power source, you have to take AC power. Then you have to to convert the AC into DC, you need a diode. So this is diode. From the basic, you will get diode. Then not from basic, from a place diode, written here place diode, you will get diode. Then diode you can MUR. So MUR family, there means so many diodes are coming. So you can take any MUR diode, that is let I have taken this one, MUR 110G. Okay, so this is your diode, and then you need a resistor, that is R load. From the basic, a resistor, put a resistor here, then do the connections. So supply voltage, you can give any supply voltage, because I already told you circuit should not be same for all. So let's say I am taking here 110 volts, and this is 50 hertz, or you can take, okay, 110 volt 50 hertz. Then display the value, then diode no need to put the value, means that there is no option for putting the value of diode, because it is a means inbuilt configured diode, so no need to put the value, only you can display the number of the diode. Then resistance you can put here, let's say 60 ohms. Okay, then display the value of resistance, then make the connection. So diode is connected in series from supply source to load, then ground the circuit to avoid simulation error. Now here the input part is completed, means the circuit part is completed. Now we have to modify the circuit, means we have to measure, means we want to measure the value of parameters. So first option is here, that is probe. Using probe, if you connect a probe to output side and a probe to input side, then you can get the values. So from the input side, what is the peak to peak value, RMS value? So see, RMS value 1.33, this is input voltage, 20 volt output voltage. So this values are coming here, we are getting the values. Now using probe you can measure it, otherwise using a voltmeter and ammeter you can measure the parameters, voltmeter and ammeter. So from the indicator you will get voltmeter, vertical voltmeter, you have to connect across the input side. Similarly another voltmeter you have to connect across the load. Then this voltage should be AC because it is set, the setting is in DC, so you have to change it, otherwise it will show wrong value. So similarly this voltmeter, a diode is connected means it will measure the DC voltage. So you will get the value of voltage of AC supply, that is 110 mA, 109.992, so approximately 110. And here this voltage across the load is this much, and the drop voltage here how much you have to, if you connect voltmeter across this, you can get this voltage. So now let us see the waveforms. Waveforms, for that, suppose you want to measure the current, you can connect a ammeter. On the indicator there is option of ammeter, and ammeter you connect in series from diode to this load. Now you will get the value of voltage, input voltage, this one 110 volts, output voltage 38.4 or 38.5 volts, and output current is 0.641 ampere. Okay, 642 ampere. So these are the numerical values you are getting, or the measured values you are getting. But if you want to waveforms, if you want to see the waveforms, then you have to connect scopes. Then for that, this is one method of measuring the values. Using scope we can also trace the waveforms. Let's say this connection, or again I am doing this. So this is a probe. Here you can see on the bottom corner of the right side there is a probe called current probe. So current probe set the value of current probe into millivolt into milliampere. So here it in 1. So 1 millivolt equal to milliampere. So this probe will change the voltage signal into current signal. If the voltage is 1 millivolt, it will express that voltage in form of current in 1 milliampere. So the ratio should be same, millivolt per milliampere. Now if you want to see the waveforms of current and voltage, you need a oscilloscope. Now oscilloscope you need, you can take a 2-channel oscilloscope or 4-channel oscilloscope. 2-channel oscilloscope you can see 2 waveforms. 4-channel oscilloscope you can see 4 different waveforms. Let's say I am taking 4-channel oscilloscope, and channel A is I have connected to here, to the input voltage. Channel B I have connected to output voltage, means across the load. Then output current I have connected to here, to the current probe. So output current. Then ground the circuit before simulation, as well as ground the this oscilloscope circuit before simulation, otherwise error will come, simulation error will there. So now if you simulate the circuit, you will get the waveforms, but you have to adjust this to get the waveform separately. So now first I am adjusting channel A. Channel A is connected to where? Channel A is connected to input voltage. So channel A is showing input voltage. So channel A ratio, I am just putting the position of the channel A in downward. You see in downward, this is channel A waveforms, sine wave, AC. Okay, here it is written DC, you have to change into AC. So AC waveform for channel A. Similarly channel B is connected to output voltage of the R load. So R load output voltage means this is for channel B output voltage, and the position should be like this. It is not completely filtered. 1 minute. I'm taking second kind of diode. One minute, students. Students, 1 minute. ओके, विजिबल हो रहा है ना स्क्रीन? स्टूडेंट, स्क्रीन विजिबल?
Visible, but student please respond. Hello.
Yes, sir. Yes, sir.
I just want these kinds of response from your side. Okay, when sir is asking.
सर लास्ट क्लास हम एमयूआर का कौन सा सीरीज लिए थे?
आप कुछ भी मोड ले सकते हैं। MUR 460 लीजिए, 450 और 460।
इसको थोड़ा नोट डाउन करना पड़ेगा।
हाँ, ये लीजिए, ये काम करेगा। हाँ।
ओके, यस, ठीक। ओके, सो अब देखो ये जो है चैनल ए का, हाँ, ये चैनल ए का वेवफॉर्म्स नीचे वाला है, वो सिग्नल दिखा रहा है, वो साइन वेव। चैनल बी का होता है आउटपुट वोल्टेज, और चैनल सी का जो दिखा रहा है वो आउटपुट करंट। ठीक है, तो आउटपुट करंट सिग्नल ऊपर में है, ये वाला आउटपुट करंट ना। अब देखेंगे इसको, ऐसे तो इसको मेजर नहीं कर सकते, यहाँ पे उसका वैल्यू देख सकते हैं चैनल ए और बी और सी का, लेकिन यहाँ पे ग्राफर का जो ऑप्शन है, ग्राफर का ऑप्शन से हम इसको ट्रेस कर सकते हैं। जैसे मान लो ऐसे में कुछ सिग्नल्स लिया चैनल ए बी सी का, सो उसका मैं अच्छा से उसको रिज्यूम करके करूँगा। चैनल ए का पहले निकालता हूँ। सो चैनल ए का एक मिनट, स्टूडेंट्स, सबका 0 ले जाता हूँ अभी रेफरेंस पॉइंट में, तो ग्राफर में आ जाएगा। चैनल बी का भी 0 में ले जाता हूँ, सो दैट रेफरेंस में आ जाएगा। सब एक एक्स एक्सिस का जो 0 पॉइंट में आएगा। हाँ, अभी मैं पोजीशन चेंज किया था वेवफॉर्म को सेपरेट देखने के लिए ऑसिलोस्कोप के थ्रू, तो इसीलिए यार अभी देखो आएगा सब। तो अभी मैं सिमुलेट किया तो तीनों वेवफॉर्म मिलके आ रहा है। अब ग्राफर में गया, ग्राफर को ऑन कर रहा हूँ। अब देखो इसको सिमुलेट किया थ्रू ग्राफर। ठीक है, अब इतना सिग्नल्स में ले रहा हूँ, उसमें से चैनल बी चैनल सी जो है बाद में लूंगा। देखो ये चैनल ए का है, चैनल ए का यहाँ पे जो सिग्नल दिखता नहीं है, इसको अच्छा से देखेंगे तो जूम करना पड़ेगा। तो बोले मैं वर्टिकल जूम को मैं एडजस्ट करूँगा। अब देखो वर्टिकल जूम एडजस्ट हो गया। अभी हॉरिजॉन्टल जूम है उसको एक्सपेंड करूँगा। अब देखो ये साइन वेव आ गया। सो ये हो गया तुम्हारा वेवफॉर्म्स ऑफ चैनल ए मींस इनपुट वोल्टेज, वेवफॉर्म्स ऑफ इनपुट वोल्टेज। तो हेलो, समझ में आ रहा है? तो यहाँ पे कर्सर और शो कर्सर से यहाँ पे कर्सर से इसका वैल्यू को ट्रेस कर सकते हैं। हाँ? 2 रेफरेंस ले सकते हो। तो यहाँ पे एक रेफरेंस लो, एक रेफरेंस में कितना वोल्टेज आ रहा है विथ रिस्पेक्ट टू टाइम, तो ये हो गया इनपुट वोल्टेज। सिमिलरली तुम्हारा जो वेव फॉर्म है वो मैं उसको काट दिया और एक बार कर रहा हूँ। हाँ, यहाँ पे अब देखो चैनल बी का, ये है चैनल बी का वेव। अभी चैनल ए का वेव फॉर्म को मैं अनसिलेक्ट किया, चैनल बी का वेव फॉर्म देखो, ये हाफ वेव आ रहा है, हाफ वेव आ रहा है। दिस इज यूनिफॉर्म एंड दिस इज फास्ट, तो पॉजिटिव साइकिल का आ रहा है। सो ये हाफ वेव आउटपुट वोल्टेज आ रहा है। हाँ, आउटपुट वोल्टेज आ रहा है। देन चैनल सी का क्या आएगा? हाफ वेव आउटपुट करंट, करंट कम आ रहा है इसीलिए इसका वैल्यू दिखा नहीं रहा है। तो यहाँ पे वर्टिकल जूम करोगे तो करंट का वैल्यू तुमको दिखेगा। नाउ यहाँ पे करंट का वैल्यू आ गया, तो ये तुम्हारा करंट का वैल्यू है। ठीक है, सो आउटपुट वोल्टेज, आउटपुट करंट, इनपुट वोल्टेज, वो 3 को एक्सप्रेस करना पड़ेगा। ये एक तरह का मेथड है यूजिंग ऑसिलोस्कोप। ठीक है, यूजिंग ऑसिलोस्कोप, हाँ, एंड यूजिंग ग्राफर, ग्राफर को यूज करके, ऑसिलोस्कोप के यूज करके तुम यहाँ पे जो वेव फॉर्म्स को ट्रेस कर सकते हो। और दूसरा ऑप्शन है तुम्हारा एनालिसिस। तो जाओगे सिमुलेट, एनालिसिस, देन यहाँ पे, हाँ, ये करने से पहले ये ऑसिलोस्कोप का जरूरत नहीं है, सिर्फ सिंपल सर्किट कर दोगे, वो सर्किट हो गया, इसमें और जरूरत नहीं है। अभी जाओगे सिमुलेट, एनालिसिस, ट्रांजिएंट एनालिसिस में जाओगे। ट्रांजिएंट एनालिसिस में सपोज तुम 0.02 सेकेंड के लिए ले रहे हो या 0.2 सेकेंड के लिए ले रहे हो, 0.2 सेकेंड के लिए देखेंगे तो क्या देखेंगे कि यहाँ पे आउटपुट वोल्टेज कितना है और आउटपुट करंट कितना है। तो यहाँ पे देखो आउटपुट वोल्टेज को देखने के लिए ये ऑप्शन है, यहाँ पे पता नहीं चलता है कौन सा वायर है। अभी इसको लेफ्ट क्लिक में सिलेक्ट करो, राइट क्लिक करो, प्रॉपर्टीज में जाओगे तो दिखेगा नेट नेम कितना लिखा है, नेट नेम लिखा है 2। तो उसका मतलब ये जो वायर है, ये वायर का सीरियल नंबर है 2। तो इसमें जो वोल्टेज जाएगा उसको लेंगे V2। ठीक है, ये वायर का सीरियल नंबर कितना है, प्रॉपर्टीज में जाओगे ये 1 आता है। तो यहाँ पे देखोगे V1 का मतलब इनपुट वोल्टेज, V2 का मतलब आउटपुट वोल्टेज। ठीक है, I2 का मतलब आउटपुट करंट, I2 लिख सकता है और IR लिख सकता है। सो अगेन मैं जा रहा हूँ सिमुलेट, एनालिसिस, ट्रांजिएंट एनालिसिस, उसमें आउटपुट में मैं दे दिया, क्या दे दिया कि V1, क्योंकि नेट नेम 1 पे लिखा है यहाँ पे, सो V1 मीन्स इनपुट वोल्टेज, यहाँ पे दे दिया V1, आउटपुट वोल्टेज को दे दिया V2 एंड आउटपुट करंट को दे दिया IR1, ऑलरेडी लिखा है यहाँ पे R1 है ना, R1 के थ्रू जो करंट जाएगा तो उसका ऑप्शन डायरेक्ट दिया है IR1। तो IR1 ऐसे डालने से क्या होगा, सिमुलेट करने से वेवफॉर्म्स मिलेगा। अब देखो ये वेवफॉर्म सब 0 से शुरू होता है और ये इजीएस्ट मेथड है, 0 से सब रेफरेंस पॉइंट शुरू होता है। सो इसको व्हाइट कर दो। अब तुम क्या करो, पहले V1 का वैल्यू ले जाओ, अभी रेफरेंस 0 से शुरू हो रहा है। कर्सर में भी देखो, यहाँ पे कर्सर का वैल्यू सब 0 शो कर रहा है, यहाँ पे अगर लोगे तो इंस्टेंटेनियस वैल्यू शो करने लगेगा। हाँ, सो ये हो गया तुम्हारा इनपुट वोल्टेज का पैरामीटर। ठीक है, मैग्नीट्यूड उसका, और अकॉर्डिंग टू टाइम, टाइम में दिया था 200 मिली सेकेंड, तो और 100 मिली सेकेंड दोगे तो उतना वेवफॉर्म्स आएगा डिपेंडिंग ऑन योर टाइम। ठीक है, सो उसके बाद देखेंगे जो V2 का, तो V2 को, V1 को अनसिलेक्ट कर दो, V2 को सिलेक्ट करो, तो देखोगे यहाँ पे 0 से शुरू होता है रेफरेंस, 0 से शुरू होता है, देखो यहाँ से सब 0 है। सो 0 से देखो यहाँ पे 0 से क्या आता है, उसका वैल्यू जो है ये वेवफॉर्म शो करता है हाफ वेव वोल्टेज, आउटपुट वोल्टेज। और यहाँ पे उस तरह IR1 करंट को सिलेक्ट करोगे तो करंट का वैल्यू तो कम है इसीलिए दिखा नहीं रहा है, क्योंकि करंट का वैल्यू वोल्टेज का वैल्यू वोल्ट्स में है लेकिन करंट का वैल्यू मिली एम्पियर में है, तो उसको बढ़ाना पड़ेगा। तो कर्सर का जो वर्टिकल जूम है उसको सिलेक्ट करोगे तो कर्सर का जो इसका वैल्यू तुम बढ़ा सकते हो। तो अब देखो ये करंट का वेवफॉर्म आ गया, करंट का वेवफॉर्म आ गया, करंट वेवफॉर्म को भी तुम यहाँ पे मेजर कर सकते हो। तो ये दूसरा मेथड है जिसमें हम क्या करेंगे, करंट को इनपुट वोल्टेज, आउटपुट वोल्टेज एंड आउटपुट करंट को, उसका वेवफॉर्म्स को देख सकते हैं और उसका वैल्यू लिख सकते हैं। एक दूसरा मेथड क्या है, यूजिंग ऑसिलोस्कोप वी आर डूइंग सेम थिंग, यूजिंग एनालिसिस वी आर डूइंग सेम थिंग। तुम्हारा जो प्रोसेस तुमको जो अच्छा लगेगा उसी प्रोसेस में सिमुलेट करोगे, ठीक है। लेकिन जब हम टेस्ट लेंगे तुम्हारा, यहाँ पे क्वेश्चन में रहेगा डू द सिमुलेशन विदाउट मीन्स विथ CRO, डू द सिमुलेशन विथ CRO देके करना है तुमको, दिखाओगे तो फास्ट वाला मेथड में करोगे। डू द सिमुलेशन विदाउट CRO विथ एनालिसिस तो दूसरा मेथड में करोगे। समझ में आ रहा है सबको? हेलो, सुन रहे हो सब?
यस सर, यस सर।
तो ये हो गया तुम्हारा आर लोड का। उस हिसाब से यहाँ पे आर एंड एल लोड लेके तुमको कैलकुलेट जो वेवफॉर्म्स निकालना है, इनपुट वोल्टेज, आउटपुट करंट यूजिंग आर एल, और उसके बाद यूजिंग आर एल ई विथ फ्री व्हीलिंग डायोड। फ्री व्हीलिंग डायोड मीन्स एक रिवर्स बायस में तुमको एक डायोड देना है, ऐसे ये डायोड है, नॉर्मल डायोड देना है, वो जो आपको तुम्हारा 1N4007 वाला डायोड दे दोगे तो होगा, ठीक है। इसको तुम ऐसे रिवर्स मोड में, रिवर्स बायस मोड में भी दे सकते हो, तो उसको बोलेंगे फ्री व्हीलिंग डायोड। ये नहीं, ये इसको फ्री व्हीलिंग डायोड बोलेंगे। और ब्लॉक करेगा करंट जहाँ पे सर्कुलेट मींस क्लोज होगा ये में, उसको ब्लॉक करेगा, शॉर्ट सर्किट करने नहीं देगा। तो वही इसको फ्री व्हीलिंग डायोड बोलते हैं। यूजिंग फ्री व्हीलिंग डायोड यू हैव टू सिमुलेट आर एंड एल लोड, विथ यूजिंग फ्री व्हीलिंग डायोड यू हैव टू सिमुलेट, ठीक है। और उसके बाद यूजिंग आर लोड हो गया, आर एल लोड हो गया, आर एल ई लोड हो गया, सब में तुम्हारा इनपुट वोल्टेज, आउटपुट करंट, और जो और थोड़ा ज़्यादा निकलेगा उसका जो वैल्यू तो बहुत अच्छा है, हाँ, डिपेंडिंग ऑन यू। कुछ स्टूडेंट है बोल बोल के क्या करेंगे, कॉपी करके दूसरे से 4-5 एक्सपेरिमेंट को ऐसे करके दे देंगे। जैसे कुछ स्टूडेंट है बिना बोल के तो खुद मेहनत करके, मैं जितना बोला हूँ वो अपना आप मेहनत करके उसका फिर 3 गुना अच्छा करके देंगे। तो डिपेंडिंग ऑन यू, एवरीथिंग इज डिपेंडिंग ऑन यू, ठीक है। मैं फेस किया हूँ स्टूडेंट्स को। तो एक चीज मैं बोला हूँ, सपोज एक चीज मैं एक टेक्निक उनको बताऊंगा, तो कुछ ऐसे स्टूडेंट्स है जो अपना बहुत सारे टेक्निक्स निकाल के मुझे बताएंगे कि सर ये भी ऑप्शन है, ये भी ऑप्शन है, इसमें भी आता है। सो और कुछ है जिनको बोल बोल के नहीं करेंगे कुछ। सो डिपेंडिंग ऑन यू, तुम कौन सा कैटेगरी में जाओगी, ठीक है। सो ये था तुम्हारा आज के लिए। आज तो न्यू ईयर है तो इतना तक तुम कंप्लीट करो, हाँ। तो आज मैं ज़्यादा क्लास नहीं लेता हूँ, तो इतना तक तुम कंप्लीट करो। जो डायोड पार्ट वाला कंप्लीट कर दो जितना भी है, यूजिंग फ्री व्हीलिंग डायोड एंड विदाउट फ्री व्हीलिंग डायोड। नेक्स्ट क्लास हम जो थैरेस्टर के ऊपर जाएंगे, ठीक है। सर
हाँ,
हेलो,
आप अच्छा
हाँ
था।
सर,
हाँ.
सर आज के लिए इतना करेंगे।
Okay, this is I think okay. So today is New Year, so again I just wish all of you very happy New Year. So all of you, our relatives, that we are all the time wishing that how fast that Corona situation is over. So that is only wishes. Okay, so as it is New Year, so you can at from
ज्यादा
our
टाइम
end.
हम नहीं लेते हैं, ज्यादा टाइम
Yes,
नहीं लेते हैं न्यू
yes,
ईयर,
yes.
इसीलिए। नहीं तो
Okay,
तुम्हारा
so
और एक घंटा तुमको मैं ये करने वाला था। अभी मैं ज्यादा टाइम नहीं लेता हूँ। ओके,
okay, I think that is enough for today. Okay, so Ramaprasad, please tell them.
हाँ सर, ठीक है ठीक है, अब तो सब बोले हैं, मैं और क्या बोलूंगा, और कुछ नहीं।
Okay, okay.
तो इतना बोलेंगे कि जो
Can we do this all in Simulink?
मल्टीसिम में करना है, अभी मल्टीसिम में करना। हाँ, ये एक्सपेरिमेंट दोनों में नहीं होगा, ये सिर्फ मल्टीसिम में करो। आगे जो एक्सपेरिमेंट सिमुलिंक में होगा मैं बोलूंगा। फास्ट जो 2 एक्सपेरिमेंट है वो मल्टीसिम में करोगे, ठीक है।
Hello, sir.
Sir, can we use Simulink from MATLAB also to do such experiments?
No, the means you can use, but for not means for
No,
this
actually,
experiment.
Ramaprasad, can I speak?
हाँ sir, बोलिए बोलिए.
Okay, so please tell me your name. Who is asking me that question?
Sir, Pruthak.
Oh, Prithak. Okay, so your suggestion is good, no problem. There is no doubt, but there is some motivations why we are using multisim. Okay, so before starting anything, okay, so we need to be very clear why we are doing. Okay, why we are using multisim. Okay, in early days is what happened. You can also follow OrCAD's PSpice also. Okay, so why we are choosing the multisim? First thing is that in MATLAB there is no such specification of the component. Like any of the MOSFET you can pick over there. So there is no no specific
Only one diode is there.
only one diode
Only-
is there. You can change the parameter of the diode. Okay, as per your requirement, but there is no batch number, no model number is mentioned in MATLAB. But in multisim, if you want to pick any of the component, you have to know about the history of those component. If it is analog component, if it is analog electronics component, or it is power electronics component, what type of voltage source you are considering? Is it digital voltage source? Is it analog voltage source? What type of ground you are taking? Here you are using analog ground, so some digital ground also be there. Okay, so picking of the devices is another important thing, that is identification of the devices. That's why few of the experiment will be covered in multisim for your better idea. Okay, for realizing of the component or device of your power electronics component. Okay, and MATLAB definitely will use. Okay, basically the computational analysis means very sophisticated analysis normally done in MATLAB. Okay, so that will also be included in our syllabus. So here you can use two things. If multisim is available with you, you can use multisim. Otherwise, another option is there, that is your OrCAD PSpice. You can also use the PSpice software also, which whatever you are whatever you are getting familiar, you can use it. But in case of PSpice, you are getting same type of response also. Okay, there is no problem.
Yeah.
Tell me.
Can we use Proteus?
Now Proteus is basically, you can get the simulation in Proteus, but Proteus, what happened? You are using the Proteus for especially for the PCB design. Okay, but Proteus you can also use. Basically analog means where the components, batch number, everything are available, you can use Proteus also, no problem. But the response, that means the simulations as per sir already discussed, it should be there. Okay, you can use Proteus, you can use OrCAD PSpice, you can use also Spice software also be there. Okay, but NI Multisim is easy going software actually. Why we are picking NI Multisim? If you go for OrCAD PSpice, again it is not open source software. Okay, otherwise you have to download the crack version or you have to use that student version. In Multisim, same thing also been available, but having better user friendly. Multisim is more user friendly compared to your PSpice. Okay, or Spice software I didn't use. Okay, but I don't know about the Spice, but in case of Spice, Proteus also you can use it, but it is again it is not open source software. It is you have to download the crack version. Okay, then you can use it. Okay, so whatever maybe you can use. So Multisim is easygoing software. That's why we pick the Multisim. That's the basic motivation. So we are not doing anything without having any motivation. So that is your first thing. So the first consideration. So what is the motivation of this subject? What is the motivation of this study? Okay. Ramaprasad.
Yes, sir.
Okay, na? So okay, so today here we are going to conclude it about our studies, about our simulation. So after that your attendance will be called by the Ramaprasad sir, then we can